it is very easy to send Blueprint variables into PCG and use them for whatever you'd like. You can throw in even data assets or anything else. You can even have those set up in the component of the PCG itself. But what happens when you want to take those attributes inside of that PCG component and assign them to the blueprint itself? What if you want to know all of the locations of all of the points? What if you want to know the densities? What if you did some calculations, like figuring out what certain things are in the world or certain types of things inside of the PCG graph, and now you want to know something about them. You want to know which points have that attribute on them, which points had the tag once you filtered everything out, etc., etc. Well, prior to at least 5.8, if you want to get an array of stuff, if you want to get all of that information, it hasn't been a one-node solution. So I want to show you how that's not only possible, but just why I think people are kind of sleeping on this. This right here is a very basic, just bunch of cubes. They're all aligned. It's nothing important, but what is important is over here in the actual detail panel of this actor. You can see there's a bunch of density here and a bunch of transforms of all the points, and they've been assigned. And if I was to update this by just moving it over, you will see all the values get updated based on what it is. If I go ahead and open up the transforms, let's say in point 1, there's the location of that point, and we can go ahead and adjust it and go like this. Now, again, you might be thinking, okay, well, I don't really need these. I just use them inside the PCG graph. But here's the interesting thing. What you can absolutely do using this method is just use PCG to find you locations, and then you just have them without the graph. Because what I can do now is, now that these are set, I can go to the PCG component, clean it up to remove everything, and then I can just remove it and the box collision, and then I just have an actor with these variables, and I can just do whatever I want with it. And if I go ahead and save, let's say go to another level, and then reopen the level, this actor will still have all of these set. So I can actually turn PCG into effectively just a sampler for the blueprint using this method. And it's actually not too complicated to do either. And if you really wanted to, you could have a very complicated PCG graph that has a lot of computations, a lot of calculations, and then you just output all those points, save them, and then you just read them back. If there are set locations, nothing's stopping you from just doing that. So you have one PCG graph, for example, do all the heavy computation, and another one that just spawns things once that one is kind of set in stone. Now, it's not for every use case, but I want to show you guys how this is done, how simple it is to implement, and get you thinking about potentially taking some of that information from the PCG graph into the blueprint. Let me show you. To get started here, of course, as always, go to Edit, Plugins, search for PCG, and make sure your Procedural Content Generation Framework PCG is enabled, and if it's not, turn it on and restart your engine as needed. We're of course going to need a couple of things. Let's grab ourselves a Blueprint actor by right-clicking, going to Blueprint Class, selecting ourselves a regular actor. I'll just call it something like BP_PCG Attributes. And then I'll also right-click, go to PCG, grab ourselves PCG Graph, empty graph. I'll call it something like PCG_Assign Variables. Now, normally, we would go into this blueprint actor, and then we would add the components. But in this case, we're not going to. You can, if you always want to assign it back on itself and just have it there, you absolutely can. But I'll show you that you can actually make it so you can just add it to pretty much anything with a little bit of a tweak that I'll mention down the line. So that way you can get that information and assign it to anything. And fun fact, using this method, you don't have to assign variables to the blueprint that spawns the PCG graph. You can assign it to whatever you want. And it's all happening mid-generation, not at the very end, right in the middle. The one things we do need to do is have a few variables. So I'll make a new variable. I'll make one called transforms, and I'll do a transform type, and I'll right-click, convert it to an array. I'll also make it exposed so we can see it. This is not required, but it allows us to actually see the numbers really easily. And this way they are saved, because when it is exposed to the editor, it will automatically be saved on the editor level. Let's go ahead and save transforms. Let's also do densities. So this is going to be just a float array. I'll also make it exposed so we can see those values. So by default, there's nothing in these. They're simply blank. So we can just take this actor and bring out into the world, and there we go. It is just there. It has nothing on it. So let's set up the actual PCG graph. Now we're going to need to do very little for this actual PCG graph. The main thing we need to have is a reference to the actor, that blueprint, for what we need to do. And thankfully, that is very easy to do using getActorData. We want to do the spatial getActorData, and in here, under mode here, you can change parse actor components to getActorReference. So imagine like in blueprints, you could just do get reference to self. That would be like this, but it's grabbing it from that blueprint. Although there's nothing stopping you from doing actor filter all world actors by tag and having a bunch of actor references to different things. In my case, myself is fine. I just need to get the parent one, but just know that you can just tag a bunch of different stuff and trigger things on all of them, even if they're different actors entirely. Okay, so we have this get actor data with the actor reference. Let's go ahead and make some points. I'll choose a simple create points grid for this test. All I'm going to do is just change the coordinate space to local component. And now I'm going to just give it a little bit of density noise. So I'll just do a density noise, which is just an attribute noise here that is set to density input 0 to 1. But if you'd like to, you can absolutely change this. For example, we could just set it to be 0 to 10, whatever you'd like. We can adjust it later. We can make any computations. So for example, if we wanted to, we could say 0 to 10, then we can round that number, and then we have a value that's an integer, and then we can save that number. We're not stuck with just the default point information. You could save whatever you'd like. But of course, we need this actor reference. So let's go ahead. Let's do an add attribute. And this is the parameter version. We want to add this attribute, this get actor data. And then for this add attribute, I'm going to give it an output target name of owner. The name doesn't really matter. Just make a note of it. And now we can just do a simple static mesh spawner at this point, just so we can see something. We'll add a mesh entry here, add a simple cube here. And you know what? Just so we have a little bit of variation, so it'll be easier to tell, I'll just go ahead and do a transform points here. And I'm just going to vertically offset them between 0 and 100 and scale them between 1.0 and let's say 0.7. So that way visually we'll be able to see them all apart. Now this isn't saving the actual information as of yet. And it's in this graph here, it's not actually on the actor. If we want to add it to now this actor, we can just come into the detail panel and just click add. And we need two things. We need a box collision. The reason we need a box collision or any collision of this type is because that way it knows kind of the bounds of the actors and then it knows its location a lot better. And so things like the local component is not getting confused. It's a good habit to get into just to have some kind of volume on the graph. Now, it doesn't have to have collisions or anything. You can turn all of those off, but it's good to have one. If you already have some kind of volume, you're good. You don't need it. But since it's just a blank actor, this is what I'm adding. And of course, the other thing I need to do is just add the PCG component here. And here I can just go ahead and plug in the graph. At this point, I click generate, and there's all our cubes. Now, cool, we have our cubes. That's all good. But of course, if I go ahead and select the actor itself, none of the information is coming through. So how does this work? Well, those of you that have been with me for a really long time since near the start will remember my 5.3 building series. In it, I use custom nodes inside of PCG, basically blueprint nodes, so we can use custom functionality. Well, we're basically going to be using that, but it's the new version, so we're not using that deprecated one anymore. We'll be using the new one, although you can do this in the old system as well. It'll just be a little bit different. I'll be showing it for the new one, but if there's enough of you guys stuck on the old system in the very early versions, let me know, and I might do a little bit of a follow-up video. So all we need to do actually is create this. So I'll right click and go to Blueprint class, and I'll open up all classes, and I'll search for Point Processor. This gives us a few different point processors. We really just need the simple element point processor here. I'll go ahead and select it, and then hit select. I just named it something like PCG BPP for PCG Blueprint Point Processor, and of course send variables. And the way it works is you just grab it and drag it in, and you'll see you get an execute blueprint node. So now we can actually plug it in wherever we want. So let's say we can plug it in right over here. You will see that, oh, all your stuff is gone. Don't worry, we'll get it back. Let's go ahead and just double click on it to open it up. It opens up a pretty familiar looking interface if you've ever worked with blueprints. The main things are really that you need are going to be here in the functions override section. If I open up the override, you will see that we have a few overrides. We can change what happens at the very beginning. We can change what happens on the loop. So if I open up the point loop body here, you will see that by default, there's nothing here. So if I wanted to, I can just say in point to out point and return value true means keep this point. So if I go ahead and just compile this, you will see that, hey, all of our cubes are back. The default setup of this is the point body doesn't do anything. So we need to override it to have some kind of information. So there we go. We're now just taking all the points and outputting them. Nothing is changing. Now, there's going to be two ways of setting that information. One where we go through every single point and then go ahead and do something with it. So since we're trying to save to an array, we can just do an add to an array. And the other way I'm going to show you is how to do it without the loop, where you just take the array of information and just assign it. Let's go ahead and do the point one since we're already here. So how does this work? Well, let's go ahead and just detach this for a moment. And we're going to need to output the points anyway. So I'm just going to right click and search for in point and then scroll all the way to the bottom here till we get this get in point, which is this one here. You could see this is the function input one. So I'm just going to be outputting the points. And this way, wherever I put this, we know that it's going to output the points. And if you'd like, you can also use a sequence and just say, okay, just go ahead and output the points after whatever we're doing here on the sequence. So that way you don't have to keep moving this if you keep changing things here further to the right. So the first thing we're going to need to do is get the information of that blueprint, right? We need access to this actor that we set right here on this attribute. If I press A here, you will get the information about all of these points. And if I scroll all the way to the right, you'll see there's owner. I go and open it up a little bit bigger, right? And you'll see more of that full path. If I hover over it, it's a soft object path. So that's the type of variable it is. If I hover over, for example, over index, it says integer 32, position is a vector, rotation is a rotator, scale is a vector. It tells you the type of variable it is. So our owner here is a soft object path. So now in here, we can get that information and we can get it using the get soft object path attribute. Right here under metadata, get soft object path attribute. We'll go and grab it. We'll plug that all the way through. Now the point is of course going to be the in point. So we'll plug that through and we need metadata, PCG metadata object reference. Now that is actually very simple to get as well. We can get it from the point data. We just drag out and search for metadata. And here we go, constant metadata. We just grab it and plug that into metadata. It's as simple as that. And now we can get a soft object reference of this name. So in my case, right, we're calling it owner. So I want to get the name of this. Now this outputs, in this case, a soft object path structure. So that's not quite what we need. So instead here, I'm just going to drag out and search for reference. And we can convert it to a soft object reference. And because this is technically in a function, to load it, we need to use the load asset blocking. So this will just load this reference so we have it access to it. Here we go. We now have it, and this outputs an object reference, which is great. And if we want to, we could at this point just go use a print string and just plug this in to get the display name here and compile. And when I take a look here and let's say update it for a moment, you'll see BP PCG attributes, and that is the name of this actor. And if I go ahead and make a copy of it, you'll see it says BP PCG attributes 2. It's not for very long, but you can see here we now get the update of which one it is, and it's grabbing the name. At this point, you can get rid of those. And as you might imagine, with a reference to that actor, we can just cast to it. So now we can just do a cast to BP underscore PCG attributes. And now we have access to it. Now, right here, you can make a Blueprint interface setup. So if you set up a Blueprint interface, you can make this call to anything that implements the interface. So you can do get all actors of tag and then throw it into a Blueprint interface and send the information that way. That's not really part of this tutorial that we're doing, but there's a lot of Blueprint interface videos on YouTube. If you need to, though, let me know in the comments below, and I'll be happy to do a follow-up. But now that we have it, we can just do a simple get transforms and get the variable, as well as the get densities. Now, if we go ahead and just add to it, because this is going one point at a time, right? If I go ahead to add to this, this will end up with having it stack. So if I go ahead and go densities, also do add, right? We do one after the other, we'll add to one, we'll add to the other. You will see that we'll just continue adding them up. So we'll address that in a moment. But let's go ahead and get the variables itself, the values. And that's just from this endpoint. We just grab this endpoint, we can bring it over here and just do a simple break PCG point. There's our transform, there's our density. We have all the other default values here as well. The seed, the color, the bounds. We're just adding the transform here and the density here. And with just this simple setup, I'll go ahead and compile this. You can see here, there's the transforms with all the values. There's the scale, there's the locations, same thing with the densities. But if I go ahead and just move this and update this, you'll see, oh, now we have 200. Yeah, we're going to be adding more and more each time. So with this method, you need to make sure you clear this every time. One way of doing it is by going into the Blueprint actors construction script, and over here we just grab the transforms and grab the densities and just do a clear on the construction script here. So we'll just do clear on both, and this way it'll first clear it and then we'll run the rest. So I'll compile, we can go in here and just go ahead and regenerate it. So I'll click generate now. If I go to the blueprint now, we can see there's the 100 values. We can open up the densities. There's all our densities, right? It's all working, though I don't recommend doing it per point, especially because then we have to load this every single time, right? This gets us the information, but we have to cast to it every single time on every single point, get through this, load it. Let's not do this. Instead, let's just promote this to a variable. Let's go right click, promote to a variable. Now let's call it BP PCG attributes reference. I'll plug it all the way through here. And inside of these two, I'm just going to use that as the information for here. So basically what I want to do is detach this here. We'll make use of this sequence. Plug it into one, just like so. And what I want to do is basically use this variable to check if it's already been loaded. Because if it is, we don't need to do the rest. So I'm just going to duplicate the variable, right click, convert to a validated get, and then from 0, go into this validated get. And if it is not valid, then go ahead and do this. Go ahead and run this graph to make it valid so we can get it. But once we've gotten it, you don't need to go through this, load it, cast to it. We already have the reference. Go ahead and just use it. Going back to our setup here, we just go ahead and now move it over. And you'll see here, there's our densities, there's our transforms. You can see here, there's all the values. I can go ahead and move this and it will regenerate. Now you notice there's 99 this time on transforms and 100 densities. It is not 100% perfect. You see 9999. And I think it's because it just takes that little moment for sometimes that variable to become valid, where it's trying to get it, but it just hasn't loaded it just yet. I think that's what's happening. So it's not a perfect system. I wouldn't really recommend doing it this way anyway. I would recommend doing it through just getting the full array and just setting it. So instead of all this, I'm just going to take the point loop body and I'm just going to plug into the return node here. So we just get our points. And then on our graph, we can see all the transforms and densities are reset, right? We have just our normal PCG graph here. So instead of using the point loop body, I'm going to use Initialize. And based on the name, you'd think, okay, well, this triggers first. So couldn't we just set the reference here and then do the point loop body? Unfortunately, it didn't seem like the order of operations kind of worked that way. So I wasn't able to when I tried, but feel free to give it a whirl. But instead of this initialize, we can go ahead and just get the full information with the arrays. And to do that, we're going to make use of this input point data. So just drag out and search for make PCG point input range, because this is the input. We're going to use the input range. And here it says, okay, the range starts index and the range size. Well, I want to start at index 0, but I need to know how big it is. How many points are there? So I can also drag out and do a get num points for get number of points. And go ahead and the range size, that is going to be the range size. So it's going to go ahead and grab us the PCG point input range, which if you go ahead and break it, gets us point data and then the range start and the range size if we needed to. I don't really need this one, so I'm going to delete it. What I do need though is using it, I can drag out and I can do something like get, and now you can see here's all our basic stuff. Get transform values from range, get steepness seed, get a point in the range. So if you want to get a specific point, for example, you can. And here's all the base stuff, which means I can just get the transforms in range, and there's the array of all of those points. Well, let's go ahead and grab that, and let's also do a get density values from range. That gets us all of the density values. And now we need to get the actual point, because we still need to get the reference to that actor, right? So as I kind of alluded to it, drag out, get, again, point from range. In this case, it gets us a single point, which is just fine for us, because that allows us to get our reference. We just did add attribute for this. So every single point has this attribute. Every single point has the reference to the actor, which means it doesn't matter which one we get. Let's go just grab the first one. So now that we have it, we can do the same thing that we're doing here. We can just copy in this get soft object path from file name, the load asset blocking, and the cast here. Go ahead and copy it, go back to initialize and paste it in and plug this all the way through. We're going to grab the point here. The metadata is going to come from the same place as this input point data. Again, search metadata and we can get the constant metadata and just plug that all the way through to the end here. So there we go. And now that we have this cast here, or again, swap it to a Blueprint interface if you want to assign to whatever you'd like. We can just do a set transforms and a set densities because we no longer need to add because we already have the full array. And because we have the full array, we can plug it in just like so, and then come here and just grab this transforms and plug it through. And same thing with the densities, take the densities and then plug it all the way through. right? And we're setting it, which means that on this blueprint, we don't need to clear this. That can go away, or I guess I'm going to keep it here for the project just to have it, but I'll just detach it. So now we have basically gone all of the point information and gone the base values. We've gone an attribute, and then we're cast to it and set it up. Now, if you want to do something else here on Initialize, you can. You don't need to use that point loop body. You can do a loop, right? We have the number of points. You can do just a for loop. There's a regular for loop, right? Use the number of points as the last index, right? Go through that. I believe this needs to be subtracted by 1 because it's the number of points. So it'll need to be 0 to number of points minus 1. And then you can get the point from that index and then get the attributes and set them here. So you don't need to put this in the point loop body. It is just an option. So don't feel like you have to use one and the other if you don't want to. But now we just set this all up. So if we take a look here, you'll see 100, 100. If I go ahead and move it, it still says 100. And there's our values. And if I move it here, you could see it is now pretty good. And one thing about this one is it is always 100. I've never seen it drop below 100, like the other one dropped to 99 occasionally because of just how it was loading. This one, because it doesn't need to loop on every single point, it's obviously a lot better. But I wanted to show the other one regardless to know that it is possible. And if maybe you're doing some filters in there to only check for certain stuff, that might be the way you want to do it. But just know you can do all of this on Initialize, and there's our values, right? You can see I can open up multiple of these, and as I move them, right, they're all going to get updated. And at any point now, I can say, okay, I got what I needed, go to the PCG graph, do a cleanup, select the PCG component and the box component, delete them. And now on the blueprint, we just have all the values here saved. We can now do whatever we want with them. We can add more, we can subtract more, it doesn't matter. They're now for us to use however we wish. And while I am just setting the transforms and density for the example, again, you can set whatever you'd like and use only some of the points, right? Filter out the points and then use that. Because keep in mind, while I have it plugged in here, nothing is stopping you from doing a filter of some kind, let's say a filter attribute elements, and only doing this to the ones that go into the filter because it doesn't need to continue into the full execution. This is just assigning variables. So it doesn't need to connect anywhere specific, just as long as that part of the graph has it, you can just have it go off into just itself. And if you have it go off into itself, let's say I go ahead and just do something like this, right? So we just remove this and just have it go off into itself. That also means that in here on the point loop body, I don't actually even need to have these output. I can just detach all of this. It doesn't matter because we're not actually using the points or anything. And here, if I go ahead and just re-add that box collision and a PCG component, plug in the PCG graph, hit generate, there's our values, go and open up the densities, right? And there's all our stuff. Ta-da! Right, and now we're setting them again. But this time, we're actually still seeing the PCG graph itself because in this scenario, we don't care about what points this outputs. And the only reason I haven't deleted the point loop body is, again, just to have this for the actual final project that is going to be available on my Patreon. Because as always, I like to provide the project files for all these tutorials. And I want to give a big thank you to the Patreon supporters. You guys are awesome. Thank you so much for all the support. And if you'd like to join the community, the link to the Discord is down in the description below as always. Come say hi. And I am curious, how are you thinking about using this functionality now that you know about it? And if you're looking for more PCG tutorials, I recommend this one right over here. I think you're really going to like.